Hello, good morning, good afternoon, everyone. Welcome to this webinar organized by UNED within the framework of the SUTI project. Thank you very much for joining us today. My name is Sergio Martín, and I am a full professor at UNED, the National University for Distance Education at Spain. It is a pleasure to be with you today as the speaker of this session entitled Technologies for Rising Environmental Awareness. In this webinar, we will explore how technology can help increase environmental awareness and support more sustainable behaviors, decisions, and practices. Environmental challenges are becoming increasingly important in education, industry, and society as a whole. And digital technologies can play a key role in helping people to better understand their impact on the environment. During this session, I will discuss how different technologies platform and digital resources can be used to collect information, visualize data, promote reflection, and encourage more responsible environmental action. We will also consider the role of education and innovation in making sustainability more visible, measurable, and accessible. Thank you again for being here, and let's begin. Well, first of all, I would like to introduce the main aims of the SUTI project, which are educating teachers and young people in the importance of environmental protection in urban areas. The project combines suitable ambient technologies such as sensors, IoT, with inquiry-based pedagogy in search for a wider democratic involvement. Here we can see what are the technologies involved in the SUTI project, in the SUTI backpack, where we have designed and collected a set of analog and digital technologies, and especially technologies focused on Internet of Things, connected sensors that allow us to understand the importance of green areas in urban environments. Well, in the project, we have considered two ways or two types of technologies. On one hand, we have chosen some commercial tools that can be used by students, but also we have developed our own developments very well designed and adapted to the project needs. In this case, the main development has been the SUTI IoT prototype, which is a tool that allow us to track environmental data in different places of the city using a specially designed sensor that measures information such as temperature, humidity, and different pollutants that can be found in the air. So the students can compare the values obtained, for example, in a park or in a crowded street. How does this mobile app work? This is an Android app, very easy to use. The user just have to connect the Bluetooth and have the sensor and the mobile phone more or less close each other. And first we have to click on the button Connect Sensor, so we start using the data collected from the sensor. Then we start the excursion, we put a name on the excursion, and we can click the button Get Data, so we can collect different kind of values of environmental measurements in this exact point of the city. Then we can walk a little bit more, maybe to another part of the city, and collect more points. And when we finish, we click on finish the excursion, and all this information can be found in another section of the mobile app, where we can find all the available excursions with organized by name And we can see, for example, here we have several excursions with 3 measurements, 10 measurements, 2, 3 measurements. And we can enter in each one of them, and we can see in a map the different points where the measurements have been taken, and we can see all the data in graphics, how the different values of temperature, humidity, pollutants have been evolving along the excursion. For example, we can click on specific spots and find the values in this specific spot. And if we want to download this app, we just have to scan this code or go to this URL and install the app in your phone. But have in mind that you need the sensor to collect the data. So if you want to do this kind of experience, you just have to contact us, and we will lend you some of these sensors so your students can start playing with this technology. Also, in the project, other technologies has been developed. In this case, this is another mobile app called Green Tracks, which is a mobile app that, in this case, it also collects geolocated information, geolocated measurements, but in this case related to luminosity and noise. So we can see the effect of green areas in this, having in mind these parameters. Also, we have created a noise meter that we can use to walk around the city and check the level of noise on, for example, on a crowded street, on a park, or inside a house, for example. Also, we have developed an artificial intelligence tool, especially designed for children, to help them understand the importance of urban heat islands. In this case, they can use the data collected with the IoT sensor and provide here the name of the city, the season, and provide the temperature and humidity values obtained, for example, in a sunny street and in a park. And when they click Analyze, they get a text explaining in a very simple way for children, personalized and designed for children with emojis and easy explanation, why there are these differences between temperature and humidity. Also, we have created a bus excursion, including a Madrid heat island. This bus excursion allows the students to check a heat island of Madrid, and also a regular map of Madrid, and they can check how they can locate parks, for example, in the regular map, and check how these parks are visualized in the heat island map, so they can understand how the parks influence in the temperature on the city. And also we have acquired some commercial equipment to allow the students to get visual data very easily. Just carrying the sensors along the excursions, they can understand different values along the city. For example, we have acquired an industrial air quality sensor, another one which is more do-it-yourself, and we also have a soil moisture sensor, and also we have an interesting sensor which is to measure surface temperature with a laser. So we can check, for example, the temperature in a car or in a garden, in the grass, and see the difference. This is, for example, a little bit more detail of the air quality monitor that gives you information about humidity, temperature, particles in the air. And in this case, it doesn't include battery, so we need to connect it to an external power source, such as a some kind of power bank. And in this other case, this is a more industrial-oriented equipment that also provides information about particles and temperature, humidity, and so on. But in this case, it goes with batteries, so it's easier to carry for outdoor excursions. And also we have been experimenting with commercial kits for children based on blocks to help students to create block-based programming, which is very motivating for them, but with an environmental focus. So we have acquired different kind of commercial kits of this type, depending on the age and the audience. In this case, we have kits more oriented to young students, and others a little bit more complicated, oriented to older students. For example, we have the microbit, the NETSA kit, that is mostly focused for children between 6 and 8 years old, and the difficulty is very easy. And it incorporates many sensors to let the students build their own prototypes with block-based programming, which is very, very simple for them in this case. And you can see in the image, you can do different kind of vehicles that include sensors, such as distance sensors or color sensors and so on. Also, we have the Lego Spike Prime that in this case is focused for a little bit older students, 10, 12 years old. The difficulty is medium, and in this case it incorporates many sensors to let the students build their own prototypes. And in this case we have created the Green Scout, what we call Green Scout, that includes also an analog temperature and humidity sensor. So the Green Scout can go, can move, and it can collect information about temperature and humidity in different points, and as it has a color detector on the bottom, it can detect when the Green Scout is in a green area, such as grass, or if the Green Scout is in a street, and the students can compare the data obtained, the humidity or temperature data obtained. And also we have other more advanced commercial kits, such as this microbit smart greenhouse, which is intended for students between 10, 12 years old. And in this case, it incorporates many sensors to let the students build their own prototypes, such as, for example, soil moisture, temperature, humidity, and it also incorporates irrigation system with real water to help take care of plants inside of this greenhouse. And also we have M5 stack air quality, which is a different kind of programming, more oriented to older students, maybe around 12 years old. And in this case, it incorporates also sensors around temperature, humidity, particulate meter, and it also allows to create this kind of IoT environment, because it also incorporates connectivity, Wi-Fi connectivity, but in a very simple way, students can create their own IoT sensors and systems. And also we have the microbit smart city, which is even more difficult. This is for 12 or more than 12 years old. And this is more difficult because it also involves communications. It includes soil moisture, rain detection, ultrasound, servos, screens, and temperature and humidity sensors. So in this case, this is more complex, but it is also very, very useful for the students in this age, that they need bigger challenges, and they can create more complex systems, in this case oriented to smart cities. And a similar kit is the microbit smart agriculture, which also have more or less similar sensor, but it also includes a watering system and soil moisture, rain detection, and other kind of components. So as you can see, there is a SUTI tool adapted to your teaching and learning needs. So we will be happy to help you choose some of these tools to help your students to raise awareness among your students about the importance of green areas in urban environments. And well, thank you very much. Thank you very much for your attention throughout this webinar. I hope this session was provided you with a useful perspective on how technologies can contribute to raising environmental awareness, helping individuals and organizations better understand environmental issues and take more informed and sustainable actions. I would also like to thank UNED and SUTI project for organizing this webinar, and of course all of you for attending and participating. We hope you found this session interesting and valuable, and thank you again for joining us, and we look forward to seeing you in future activities of the SUTI project.